So what is a relationship? If there is an association between two entities, so it is called as a relationship. So from this picture, you can observe, from this diagram, you can observe student and course are represented in rectangles. So these two are entities, and here the student enrolled in a course. Okay, here enrolled in makes the relationship between student and course. So here there is an association between student and course. Okay, this we are going to represent in the graphical symbol rhombus or diamond. Okay, so if you understand this diagram, and we will go for next concept. So you try to understand what is entity and how we are going to define the relationship between entities. And another important definition for you is cardinality. So what is meant by cardinality means the number of times participates in the relationship. The number of times an entity of an entity set participates in a relationship set is known as cardinality. So normally we can express the number of times participation in numerical only. That's why I given again another definition below, or defines the numerical attributes of the relationship between two entities or two entity sets. So we are going to define the number of relationships in numerically. Okay, so that's why we can call it as a cardinality. So what is meant by cardinality? Very important. The students who are preparing for GATE exams, cardinality and cardinality ratio is very important. So try to know the definition very well. So then it is easy to find the cardinality in ER diagrams. And even while drawing ER diagrams also very useful. Next. So we have four types of relationships: one-to-one, one-to-many, and many-to-one, and many-to-many relationships. See here, so one-to-one, when each entity in each entity set can take part only once in the relationships. Okay, so here only one time participation. So according to our tradition, Indian tradition, so see here, one male married to one female, or one female married to one male. So here left side female, so only one female. So here we are making only one relation with, that type of relation is called married. Here association is called married to only one male. Okay, so here left side is one participation and right side is one participation. So now we can define it as a one-to-one relationship. In mathematically, so this a Venn diagram or a sets representing one-to-one relationships. Here I am taking three males and three females. Okay, and they married, here married to a relationship. So married one, male one married to female two, and male two married to female one, and male three married to female three. Okay, here so only left side one relation and right side one relation. So this example describes one-to-one relationships. I hope you people understand well. So now I am going to the next topic, one-to-many relationships. Here one-to-many. So what? Try to understand the meaning of this one-to-many. So left side only participation one relationship, and right side many relationships, that is more than one instance of entity on the right side. Okay, so when only one instance of the entity on the left and more than one instance of an entity on the right it associates with the relationship. Then this is known as one-to-many relationship. Example, here I given a scientist. A scientist as a single person. Okay, scientist can invent many inventions. Okay, you try to understand. Scientist is a single person. He can invent number of inventions. So another example I will give. Faculty or professor publishes many articles. Okay, professor is single, publishing is a relationship, many articles. Here it is associated with more than one article. And here in this example, scientist invents more inventions. So here it is associated with more inventions. So we will come from right side. Okay, inventions, any number of inventions invented by only one scientist. Only one scientist. Any number of articles published by one professor. Okay, this is the best example for one-to-many relationships. So here you can try to understand in mathematical representation. So here E1 entity 1 you can think either scientist or professor. Okay, so you can take professor or lecturer. So lecturer publishes how many papers? Paper 1 and paper 3, 2 papers. Okay, and lecturer 2 publishes 2 papers. Okay, so here more than one. So more than one. Here up to relation he participated only one association. From relation to these articles, okay, many associations. So here we are going to describe this diagram represents one to many relationship. So I hope you understand this also very well. So very important. This next one, many to one relationship. When more than one instance of the entity on the left, so left is more than one instance on the left and only one instance of an entity on the right associates with the relationship, it is known as many to one relationship. So example, I will give an example. IIT Madras, so they are going to start a new course in data science. Now it is a trending and emerging technology, data science. So what I thought, so I want to give this information to all students in Malineni Lakshmiya Women's Engineering College or some other college. Okay, so then I will give this information to all students. So number of students are interested to enroll in data science course. Here number of students are many, more than one student. Enrolled is a relationship, and here only one course. So that here only one instance. So there is a only one instance at right side. So now we can express this as a many to one relationship. So in example, here student 2, student 3, student 4 are 3 students. They are selecting the course 3, and here course 3 is only one course, and this course selected by many students. Okay, so this represents many to one relationship. So I hope you understand. Many to many, when entities in all entity sets can take part more than once in the relationship. So the same example you can take. IIT Madras introduced many courses, not only data science. So data science course, cloud computing, distributed systems, and artificial intelligence. So 4 courses. Okay, now I given the same information to students. Now some students, they want to join other than data course also. They want to join in cloud computing. Okay. So it is, they are selecting more than one course. Okay. So similarly, many students enrolled in many courses. Okay. So here many students, left side, many instances, many entities. Okay. Related to many courses, related to many courses. Okay. So here it establishes or it associates the relationship between two entity sets. So many students enrolled in many courses. So now this is many to many relationship. Okay. And here also C1 and C3, two courses selected by the students S1, S3 and S4. So here S2 is not participated in any relation. Okay, you can leave it. So okay, that we will discuss later. That is depending upon total participation and partial participation, that we will discuss later. Okay. So here courses 1, course 1 and course 3. Course 1 and course 3 selected by many students. So here I am giving only 4 students. Normally college or university, there are many students, they can take many courses, and we cannot expect all courses in the same time. Maybe some courses in the morning, maybe some courses in the evening. So like that, okay, they can opt many courses. This is also an example for many to many relationships. Now you just remember this, very important. So when we can say total participation of entity, and when we can say partial participation of an entity. So here, what is a total participation and what is partial participation? Participation constraint, only we are applying entity participates in relationship set. Okay. So just you go, what is a relationship set here? Just so here R1, R2, R3, R4 is a relationship set. This is entity set 1 and this is entity set 2. Okay. Now you understand. Participation constraint. So when we can say total participation, this is very important. See from this picture, here there are 2 lines and here there is 1 line, and this we are representing M and N. That means many to many relationship is there. So students enrolled in courses. Okay. Students enrolled in courses. So what is meant by total participation? The student must participated in the relationship. Okay. The student enrolled must enrolled in course. Okay. So the student must participated in the relationship. So here we are representing with double lines. Okay. So that means he participated with that relation. Okay, he associated, strongly associated with that relation. So then it is called total participation. If an entity may be participated, may not be participated in relationship, so then it is called partial participation. So here we cannot say must participate in a relationship. Okay. So here we can say may or may not participate in the relationship. Here enrolled in course. That means he may be enrolled in course or he may not be enrolled in course. So just from previous picture you see here student 2, he didn't participated. Okay. He don't have any relation with courses. Maybe after some time he has interest, he will join. Okay. So try to understand. What is the total participation? How we are going to represent this total participation in the ER diagram? If there is any double line, means that you have to think it is a double line, means it is a total participation. There is a single line, means may or may not be participate in the relationship.